Hello there, it's exercise 19E for Year 12 Maths. With a bit more mechanics. We're looking at average speed and average velocity and trying to work them out from graphs as well. And I suppose we need to know the difference between speed and velocity. And I mean, people in science it's always described as velocity is a vector and speed is just a scalar or just a number. But in maths, I suppose that's true, but we think of it in terms of speed has a it is just literally a number that represents how fast it's moving, whereas velocity gives it a direction too. You might know, for instance, the vector it's travelling on. You might know that it's going forwards or backwards. That might be the main difference at the moment. But anyway, let's do a few questions and then we'll see what I mean. So I'm looking for the average velocity in this question and also the average speed. And really, it's the same formula for both. But the subtle difference, I suppose, is the average speed, if I wanted to know that, would just be the distance travelled. This is kind of what you got when you was at GCSE, distance divided by the time it took you to do it. Whereas notice average velocity is total displacement. Now I'll talk about the difference of that in a bit. But let's look at, it says find the average speed for the entire journey, and also the velocity, and then for the first 6 seconds of motion. Okay, so for the entire journey, so we have to ask ourselves, if I'm finding the average speed, I have to say to myself, how far have I gone in total? And if you just look at it, I go from here to here. Now it takes me 2 seconds to do it, but you can see that's 2 meters, sorry, that I've travelled. And then I stay there for a bit, so I'm not moving at all, and then I come back home again, almost. So I've gone another 2 meters. Now it's a different direction, but that's beside the point. I've gone 4 meters, and I stay there for a bit, and then I go another, it looks like another 2 meters. So in total there, I've gone 2 meters, 2 meters, 2 meters. That's the total distance of 6 meters. And remember I said average speed is distance divided by time. It took me 10 seconds to do that. And I don't even care that some of the time I was sitting there, you know, eating my butties, whatever it was I was doing. So it's just 6 divided by the 10 seconds for the journey. And that's obviously 0.6 meters per second. That's the average speed. Now what about the average velocity? Now this says, if you look at the formula at the top, says this is the total displacement. Now all that basically means it doesn't care what happened. I went up there, I came down again, yeah, so what? Where did I end up? And I ended up there, which was 2 meters away from where I started. Oh, and interestingly, it's a negative 2 meters, so whatever direction that was, I'm now counting that as backwards. So my average velocity is minus 2 divided by the time taken, still 10. So this is minus 0.2 meters per second. So this is showing you the difference between average speed and average velocity. Average speed, how far did I go? 2 meters. 2 meters back again. That's now 4 meters. 2 meters. That's 6 meters. Whereas average velocity is where did I end up? Where's my displacement? So that's part A of the question done. And part B I'll do here. It says for the first 6 seconds. Well, the first 6 seconds is obviously there. Average speed. Again, I think I can do this quite quickly now. How far have I gone? 2, 2. That's 4. How long did I take to do it? 6 seconds. 4 divided by 6. Well, that's 0.6. Well, I'll do it to 2 dp. It doesn't ask how to do it. 0.67 meters per second. What's my average velocity? Well, how far have I gone? Well, actually, I've gone nowhere. I'm back to where I started. I went up 2, back down. So that's no distance divided by the 6 seconds, and that's no meters per second. Very different results, depending on whether you're looking at average speed or average velocity. So I get the answers to be those. And yeah, other than I've rounded differently here, that's right. So next question, I've got both formulas there. I've got this equation which basically says V equals T cubed. Now we've already seen, of course, that we can differentiate and integrate this to get other things. It'd be interesting to see what I need. The diagram shows the velocity time graph. All right then, yeah, so this, it starts off at rest. It speeds up, slows down, it's back at rest. Oh, it changes direction, speeds up in that direction, then slows down, and eventually, after 5 seconds, it's still again. It's at rest again. Find the displacement from the starting point after 5 seconds. Well, all right, displacement is x. I need x. So to find x, we should remember that x is the integral of v dt. And so I've got to integrate that t cubed minus 7t squared plus 10t. Now you can do this in two ways. You can do it as an integration where you get a constant and you find the constant, and that's the way I'm going to do it. You could do it as a definite integral. I'm going to find the constant root. So add a power, divide by the new power. Each time the same. 10t squared over 2 becomes 5t squared. I can simplify that, plus a constant. Now, what information have they given me? The diagram shows find the displacement from the starting point. All right. Now, the displacement from the starting point basically means I'm starting at 0 at t equals 0. So using that information, well, actually, if that's 0 and that's 0 and that's 0 and that's 0, the c must be 0. I can ignore the plus c. So I've now got my equation. And it says find the displacement after 5 seconds. So presumably I'll just write when t equals 5, I can find how far it's gone. So x is, what is it? It's 5 to the power of 4 divided by 4. Be careful I should type that in. Minus 7 times by 5 cubed divided by 3 plus 5 times 5 squared. And I get, oh right, it's a negative. So it's minus 125 over 12. I suppose I could write that a bit more friendly. Minus 10.42 meters. That's how far away from where I started. And the negative just tells me on if I was thought of positive to be the right, now I'm on the left and vice versa. So I've got those. I'm going to go on to the next page. I want now the distance travelled. Oh right, now before I do that, just look at the graph. This is a positive direction, this is a negative direction. So I've got to find the distance from 0 to 2, and then the distance from 2 to 5. Now it might be easier to do this, but use an integration like this, from 0 to 2 of my function, which was t cubed minus 7t squared, plus, what was it, of 10t. And of course we already know what we get when we do this, but the advantage of this is you can just put now from the limits of the integration in. And I already know what the answer is. It's that t to the 4 over 4 minus 7t cubed over 3 plus 5t squared, if you remember, or if you've just done it again, like I just did. And then you chuck 0 and 2 in. That will tell me how far it travels in this first section of the journey. So that's 2 to the 4. Well, I might as well just do this on my calculator. 2 to the power of 4 divided by 4 minus 7 times by 2 cubed divided by 3 plus 5 times 2 squared. And I get 16 over 3. And obviously if I put 0 in, I get 0 out of that function. So I can just say that first section of the journey is 16 over 3 meters. Now what's the second journey? The second journey, this is the advantage of this method. I can just say now go from 2 to 5 of t cubed minus 7t squared plus 10t dt. And obviously it's the same answer. It's the third time I think I've written this down. But now between 2 and 5. So I put 5 in. Put 5 into there, I get 5 to the 4. I'm just going to do it 5 to the power of 4 divided by 4 minus 7 thirds of 5 cubed plus 5 times 5 squared. And I get the same answer. Is that right? Yeah, I think it is. So, where's my pen gone? There it is. Minus 125 over... Oh, that wasn't the same one as I got before. That was the same answer as I got when I sub 5 in. Of course it is. And minus now, well, I get... Well, it's the same. If I put 2 in, I'll still get the same answer. It's 16 over 3. So, if I do that now, I am going to get... I can get this as a decimal, say minus 15.75. Just check my answer. And so if that's true, then basically in this section of the journey, it's 16 over 3, or if you like 5.33. This one's a negative, and of course that negative is because it's going the opposite way, but in total 15.75 meters travelled. And I can add those together to get the total distance travelled. Now notice if I'm on part B, which I am, which it says find the total distance travelled, suddenly the negatives don't matter, you ignore them. So adding those together on my calculator, I get 63/4. Don't know if that's right. No, if I just let's do that again. Don't think I've done that right. 15.75 plus the 16 divided by 3. 21. I knew it didn't sound right. 21.08 meters is how far I've travelled. Now, what does C say? C said, what's the average velocity? I think it said this. What's the average velocity and the average speed? So we just do exactly the same thing, but we now got two different calculations. Same calculation really, but different distances. So the first one I did, well, how far did it travel? I reckon minus 10.42 meters. Minus 10.42, and I've got to divide how long that journey took me. It took me 5 seconds. So if I do that, that sounds very suspiciously like minus, well, 2.08 if I do it on my calculator, allowing for 3-6 fix. And if the other one, well, that's also the same idea, but it's now 21.08 divided by the 5 seconds. And if I do that, I reckon it's a lot bigger. It's 4.22 meters per second. So it kind of makes a difference. This is the more realistic one. This is the one that you actually would have had to do in your car or running or whatever it is. But overall, the overall effect is that you basically just run backwards 16/3 meters. And therefore, well, it was 16/3. It was at minus 15.75, wasn't it? 10.42 meters. There you go. I'm going around in circles here. So overall, the average velocity is much lower than negative. The speed is positive. Then I get 10.4, 21.1. Were they the distances? I think they were. Oh, it's gone off the bottom of this, but that is right, and that is right as well. I've got the right answers. You just can't see it. Take my word for it. For part C. Now, how long have I got? A couple of minutes. I can start this. The velocity v of a particle moving in a straight line is given by that equation. And again, we're used to the fact that we can differentiate or integrate that. Find 2 times when the particle is instantaneously at rest. Well, it's at rest when v equals 0. So I'm just going to write 0.2t squared minus 3t plus 10 is equal to 0. Notice what I've done. It says it's at rest. Well, that's when v equals 0. So I'm going to solve that equation. Get my calculator out. I'm not expected to do this using the formula or anything, or factorising. I'm just meant to get the answer. So I'm going to go menu. I'm going to press the A. It's a polynomial equation. It's actually a quadratic, so it's degree 2. And my numbers, what are they? 0.2, minus 3, and 10. And I get one answer to be 10. Didn't expect that. So I've got t equals 10. And what's the other one? T equals 5. Obviously 5 comes first, so, but there's my 2 solutions. Hence sketch the graph. Well, it's very obviously a quadratic graph. So presumably it does this. It crosses initially at 10. So there's 10. I know that because that's the y-intercept effectively. And then it's a U shape because it's a quadratic, so it must do that. And it must hit there at 5. And it must hit there at 10. Now I'll save the rest of it because we've more or less run out of time, but it does give me 2 more questions to have a think about. And it says find the total distance travelled by the particle in the first 10 seconds. Notice there are 2 sections that I'm going to have to find the area of. And find the average speed. Well, the average speed is those distances where you're careful with the negatives. It wants speed, not velocity. So be careful with your negatives, and then divide your distance travelled by 10. And I think that will then work. I won't leave that up for too long. And then in class, once you've gone through that, perhaps one more example, we'll look at exercise 19E. Cheers, guys.